Mars Rover UAV team is consists of more than 12 students from electrical and electronics engineering and computer science engineering department. All members had to go through a lots of study and experiments during the entire process of making the rover and tuning it to its best performance. This is to mention we don't have any mechanical engineering department in our university, and we had to do this extra work like studying and experimenting on our own without any basic knowledge about mechanical.
We have used modified rocker bogie system for suspension, and another thing is we have used servo-based steering motor to steer this whole rover, and hydrodecimier gear motor to run this rover.
The chassis is made by US bar. We have used MS bar for taking stress in astronaut trucks, equipment trucks, and terrain traveling trucks, and several trucks in the University of Rover Challenge.
Wheels are designed using SS materials to take the stress of rough terrain, and the grip of wheels is considered as squeeze the surface. We are developing our wheel design to make them more efficient.
The rover arm is implemented by aluminium with 3 degrees of freedom. In base plate, a DC gear motor is used with gear mechanism for 360-degree rotation. 2 linear actuators are used for lifting heavy weight. This gripper is made by acrylic sheet with a laser sensor and a magnetometric sensor.
We are using a latest technology in our circuit. We are using ARM processor. This was help us to our system is a high-speed processor. We also have two mini PC, and we are using a infrared sensor which is find the human body. We are using a air quantity sensor. This helps to find out the quality of the air, and we also use a laser system in our hand. It's a laser technology. We made a custom PCB for our rover. Every electronic system we make a backup system.
In our rover, our total power system consumes actually 300 watt. We have divided our total power system into in two parts, light load parts and heavy load parts. Our light load parts consume 30 watt, and our heavy load part consume actually 270 watt. Our heavy load part means our motor, which for wheel, and our hand part. We have used 2 linear actuator and 1 motor for our hand part, and this is the whole part is our heavy load. In our light load part, we have several sensors. We have actually used SMPS converter for convert power. The whole power system is run by LiPo battery for as a backup in a power system. If our regular power system fail for some reason, a solar system will back up this system.
The communication between rover and control station along with an antenna is placed both rover and control system. A 2.4 GHz 600 Mbps router is used with 2.4 GHz 15 dB omnidirectional antenna used for outdoor coverage. In case of failure of communication system, we are using a backup communication system which is made by NFR2.
The rover software system fully developed by Mars Rover UAV team members. Establish a central system to control the rover from remote area. Every software runs individually and independently. The system associated with the rover can convert data which is received from sensor and camera. Software are developed by C++, C# and Java programming language. Overall control system is developed in C#.NET, which offers a user-friendly graphical user interface. To communicate with the rover, in the rover side we use Java. Rover software has been designed as a server side and the control station software as the client side, which communicate with each other through wireless data transmission, and thus implementing a complete client-server application using WebSocket. If server stops, then it will automatically reconnect with 500 milliseconds. The software is interface GPS with offline map, gyro with 2D graphical interface.
To analyze the soil sample on site, some test equipment have been used. For example, USB microscope is used to get a visual representation of soil